Architect Divya Chakravarti. She completed her undergraduate studies from SRM University and she went on to pursue her master's in historic preservation and urbanism and study of the built environment from the University of California, Los Angeles. She went on to work for the Department of Planning and Preservation for the city of Pasadena, California. She also did a brief stint of work for Historic Scotland, Edinburgh, UK. She had also worked on conservation projects like Kalsa Mahal, Gokhale Hall in Chennai, and Marimalappa Educational Trust in Mysore. She is currently working as a director of Samrakshan Heritage Consultancy. She is also a co-founder of the Artisan Reprisal of Traditional Materials, Method and Technology. She goes on to conduct workshops to revive traditional and lost methods of construction.
Welcome to the UGC lecture series for Bachelors of Architecture. The subject we are discussing is environmental science, and the topic we'll be delving into is environmental pollution. In this lecture, we'll be looking into air pollution, ozone depletion, water pollution, soil pollution, marine pollution, noise and thermal pollution. Now, if you move on to the effects of global warming, especially on agriculture, which is like the basis of anything from the ecosystem, the first hit you will receive is on the loss of biodiversity, especially in fragile environments like tropical forests. Then you have loss of fertile coastal lands, which is caused by rising sea levels. And then you have unpredictable farming conditions in tropical areas. And because of these unpredictable conditions, farmers are led to start using new advanced techniques of agricultural practices, which have not been completely researched upon, and their after effects are not known, especially with the use of genetically modified crops, or let it be the use of certain chemical or even natural fertilizers. Increased frequency of weather extremes, that is, in certain parts you would have storms, floods and extreme conditions of water, and on the other side of the spectrum you would see droughts and famine conditions. Longer growing seasons in cooler areas, increase in incidence of pests and vector-borne diseases, and there is a dramatic change in distribution and quantities of fish and seafood. So, the long-term fluctuations in weather pattern could have extreme impacts on agricultural production, slashing crop yields and forcing farmers to adopt new agricultural practices in response to these altered conditions. And the effects of these practices are still not completely researched upon. Moving on to ozone depletion. Ozone, or O3, is a very important constituent of the troposphere. Ozone is a pale blue, highly poisonous gas with a very strong odor. Ozone is considered to be a pollutant, especially at ground level. Breathing O3 or ozone affects both the respiratory as well as the nervous systems, resulting in respiratory distress, headache and exhaustion. Ozone is damaging to plants, resulting in leaf mottling and in reduced growth. So, once it starts affecting the plant system, it is the lowest level of the food chain and the transpiration is going to happen from henceforth. If it affects photosynthesis and fruit production, it is going to affect all the trophic levels of the food chain and essentially the food web. So, it is very important to keep ozone completely under control or avoid it completely. Earth's atmosphere consists of a number of different layers. The troposphere is the lowermost atmospheric layer. The stratosphere is often referred to as the upper atmosphere. The stratosphere contains the ozone shield or the layer of ozone about 50 kilometers above the ground. Now, if you look at the layers of the atmosphere above the Earth's surface, you have the sunlight coming with strong ultraviolet rays, which again is considered very harmful. You have the Earth's surface, and right above the Earth's surface to about 10 kilometers, you have the troposphere. From about 10 to 50 kilometers is the ozone and the stratosphere. So, they pretty much absorb the ultraviolet rays and send the clean sunlight without any form of radiation to the troposphere and eventually the surface of the Earth. Hazards of UV radiation or ultraviolet radiation. This can include increased mutation rate, which can lead to skin cancer, cataracts, depression of the immune system, impaired crop and tree growth, and death of the planktons. Planktons are nothing but what is found in the water bodies, and it's a very important part of hydrological cycles as well as the water cycles. What are the health effects of ozone depletion? Each 1% drop in ozone is thought to increase human skin cancer rates by about 4 to 6%. The United Nations Environment Programme predicts a 26% rise in cataracts and non-melanoma skin cancers for about 10% drop in the ozone. This translates to roughly about 1.75 million cases of cataracts and around 300,000 more cases of skin cancer every year. Now, what about the ozone hole which has been found above Antarctica? During the 1980s, scientists have discovered a hole in the ozone layer above Antarctica, and by the 1990s, atmospheric scientists had detected an annual loss of around 40 to 50% of the ozone above Antarctica, which has produced an ozone hole every spring. One CFC molecule can destroy about 100,000 ozone molecules. The largest Antarctic ozone hole ever recorded in September 2006. This Antarctic ozone hole is an area of the Antarctic stratosphere in which the recent ozone layer levels have dropped to as low as 33% of their pre-1975 values. So, this is pretty much the size that has been exposed right now. And because of this, it leads to other conditions, the first thing being acid rain. So, we will discuss what is acid rain, what are its causes and effects. Environmental impact of acid deposition, sterilization of lakes and forests, reducing the populations of small invertebrates and decomposers, reducing agricultural yields, causing extensive structural damage by corroding marble, metal and stonework, degrading water supplies by leaching heavy metals from the soil into drinking water supplies, increase in lung cancer as well as colon cancer. Wet as well as dry acid deposition. This is caused by sulfur dioxide and nitrous dioxide alone causes dry acid deposition. So, which forms all forms of water vapor is inclusive in this. This could be sulfuric as well as nitric acid, and this forms the acid rain, which is the downwind of sites of emission. So, especially above factories or nearby factories, if there is a deposition of precipitation, anything of these in vapor form, any of these acids in vapor form and the precipitation nearby is going to develop as acid rain. So, normal rainwater pH is around 5 to 5.6, acid rain is much lesser than 5. So, this affects industrialized areas worldwide, Scandinavia, Eastern Europe, Northeast United States. Developing countries do have more pollution and fewer controls than developed countries. So, because of this, even though we do developing countries or underdeveloped countries might have episodes of acid rain, it is not recorded and studied as strenuously as it's done in developed nations. So, if you look at acid precipitation, you can see the different sources of acid. You have SO2, NO2 or NO3 depending on whatever component it is, mercury, VOCs, all of these are different sources. They get collected as gaseous pollutants in the atmosphere. Then at the same time, this is dry deposition. This could happen as just settling over leaves of trees. This could happen as settling over plants, animal skin, or even human skin, which will cause irritation in eyes, watering of eyes, irritation in skin, blisters, rashes. All of these could be because of dry deposition. But then when you have particulate pollutants in the atmosphere and then you have other water molecules present, pollutants especially in cloud water as well as precipitates, then it comes down as acid rain or wet deposition. Again, the wet deposition, what happens is, it reaches the ground level directly, and that could join and combine with the water level above, below the ground, as well as rivers, seas, and all of the other water bodies. So when it comes down as a dry form, it has its own effects, and when it comes down as rain, it has its own effects. The term acid rain is commonly used to mean the deposition of acidic components in rain, snow, fog, dew, or even as just dry particles. The more accurate term is acid precipitation, because it could be in any form. Clean or unpolluted rain is obviously slightly acidic, its pH value being around 5.6, because carbon dioxide and water and air react together to form carbonic acid, which is a very mild or weak acid. Now, the extra acidity in the rain comes from reaction of primary air pollutants, which is mainly sulfur oxides, dioxides, nitrogen oxides, with the water in the air to form stronger acids like sulfuric and nitric acid. The main sources of these pollutants are vehicles, industrial plants, and power generating plants. Effects of acid rain: acidifying lakes and disrupting the normal cycling of nutrients, leaches metals out of rocks and soil. It essentially kills fish, plants, stress and defoliate trees due to moss growth, insect attack, and loss of nutrients. The primary causes of acid rain is sulfur and nitrogen compounds from human sources such as electricity generation, factories, as well as automobiles or motor vehicles. Coal power plants are one of the most polluting in the country or in the world, and the effluents that come out of this, if it's going to be sulfur or oxides of sulfur and nitrogen, acid rain in those areas are understood and accepted. Now, what are the sources of indoor air pollution? Mainly building materials and construction work nearby that's going on, cigarette smoking, pesticides, volatile organics from paints, furniture, rugs, insulation, etc. So, you have 11 common pollutants, which is about 2 to 5 times higher indoors than actually outdoors. Air inside a car is 18 times more polluted than the air outside. 17% of commercial buildings have serious indoor air pollution problems, which is referred to as sick building syndrome. And one of the main causes of this is bad air conditioning, lack of cleaning facilities in air conditioning ducts, filters, and all of that, which is not done on a regular basis as it's supposed to be done. Are there any natural indoor air pollutants? Radon gas accumulates in homes located in areas built on granite, phosphates, and shale. Synergistic effect with tobacco smoke, secondary leading cause of cancer, lung cancer. So, next sources you have is soil, groundwater, building material. All of this cannot be filtered out but must be vented out. In the sense, we have to remove it physically using certain filtration systems, and only then can it be moved out from the indoor system. If it's not going to be moved in the similar way, there is no way that this can be completely avoided. Number one, you cannot avoid having certain materials on earth. Number two, when you have groundwater that is being polluted, building materials and other construction work that is being going on, you cannot accept that these things are not going to enter the indoor atmosphere. Most dangerous indoor air pollutants: cigarette smoke, formaldehyde, radioactive radon-222 gas, asbestos. Others include bacteria, fungi, dust, and other particulates, pollen, carbon dioxide, carbon monoxide, ozone, nitrous oxides, sulfur dioxide, building materials such as fiberglass, asbestos, etc. What can we do for the future? Basically, we have to prevent pollution, but how do we go about doing it in a strategic manner? We need to have full cost pricing, that is, shift costs to the production of air pollutants, improve energy efficiency, reduce the use of fossil fuels, and reduce or decrease population growth. So, only when the population is brought under control can the usage of all fossil fuels or any energy consumption be brought under control. And if that is not going to be possible, we need to start using alternate forms of energy so that our dependency on fossil fuels and non-renewable resources comes down drastically. And we need to improve energy efficiency of buildings, vehicles, every possible venue that is there. We need to make ourselves more energy efficient and self-sufficient while providing energy. How serious is the problem of indoor air pollution? People with respiratory ailments are most affected, like bronchitis, asthma patients. They are going to be affected right away. Asbestos inhalation may cause asbestosis, lung cancer, mesothelioma. Asbestos workers, insulators, pipe fitters, shipyard employees, all of these people are prone to such diseases. And another important source is when asbestos is used in certain constructions like schools and office buildings or even colleges and other institutions, even the people using those buildings are under threat. General solutions: switch from coal to cleaner fuels, use natural gas preferably. Reduce the energy consumption, and we need to improve efficiency of energy. Burn less coal, use lower sulfur coals, coal gasification. After burning, the SO2 can be cleaned out by scrubbing, taxing emissions. So, certain industrial plants that do have emissions that are in the with sulfur compounds or nitric compounds, they have to be taxed and they have to bear the brunt of bearing the economics of cleaning the atmosphere or cleaning the air surrounding these plants. General solutions to indoor air pollution: mainly to be well ventilated, fans, and if it's going to be centralized air conditioning, that's one of the main problems. You need to ensure your filter system is really good and it's going to be cleaned on a regular basis. We need to ensure that there is no smoking allowed in any indoor atmosphere. Source modification, more efficient stuff design so that the consumption of fuel while cooking is optimized. Pollutant removals like filters in every possible way, and basic education at every level, not just schools, colleges, but also organizations, institutions, offices, every level man has to be educated on different sources of indoor pollution, indoor air pollution, as well as the effects and the ways to reduce it. What are the special problems associated with urban areas? We need certain urban trends that you would find is we need to discourage automobile use, reduce the number of cars. So, we need to increase public transportation, and the number of people using public transportation has to drastically increase. Stricter emission controls, requires electric cars or hybrid cars, improve public transportation, mandatory carpools, industrial and household controls to realize how much fuel is being consumed, and if at all there is any emission, how much of it is getting emitted. Reduce emissions completely, burn less fuel, use more energy efficient appliances as well as energy efficient homes, offices and lifestyles. Control NOx by recirculating exhaust. Catalytic converters removes carbon monoxide and hydrocarbons by converting to CO2 and water, which is completely safe. CO2 is absorbed by plants, so if plants are going to be around that area, it's going to be really useful, and water is always a welcome byproduct. Effluent fees and emissions tests to assure catalytic converters are maintained. So, if anyone are breaking these rules, they have to be penalized in the right way and not let go scot-free. So, if you look at different prevention methods, consumption should be less, use of catalytic converters, and how do we go about carpooling, using a lot of bicycles, walking when possible, avoid using a lot of fuels, motorbikes or public or private transportation, opt for public transportation. Special problems associated with urban areas. Meteorological conditions along with topography can affect air pollution. Natural ventilation occurs when winds are strong, turbulent, Mixing is good large mixing volumes. Atmospheric inversion, that is temperature inversion. Warmer air goes above cooler air, and this prevents dissipation of pollutants. Pollutants collect and therefore there is no wind. Urban air pollution, this is basically determined by rate of emission per unit area, distance downwind that a mass of air can move, the speed of wind, and height of mixing above the ground level. Now, government level prevention, if you look at it, there are a lot of laws and enforcements that are happening around now. Some governments are investing in wind energy, solar energy, other renewable sources are being given importance to minimize the burning of fossil fuels, which does cause a majority of air pollution. Governments are also forcing companies to be more responsible with their manufacturing activities, so that even though they do cause pollution, they are controlled, and if at all any effluents are coming out, they are aware of the effluents, the rate at which the effluents are coming out, and whether the effluents are being treated and not left unattended to enter the groundwater or the atmosphere. So, companies also need to build more energy efficient cars which pollute less than before. Government should provide local transportation to people to reduce burning of fossil fuels. Moving on to water pollution. If you look at the scene over here, you can see this froth over here. It is not beautiful froth because of the force of the water. This is a part of effluents coming from a small factory. This is not even a large industry. It's a small time factory, and the effluents are causing severe damage to the water. Gradually we will see these plants dying, and then you will see the fish inside this river or stream dying. So, this kind of effluents need to be recognized and not thought of as something else. Water has to be constantly treated, and whatever the size of the industrial plant, any kind of industrial manufacturing is going on, that area has to be sealed away from entering into the open atmosphere or entering the ecosystem either by ground, soil, or water or air. Water pollution exists in so many ways. Even in rural areas it occurs due to, if you are going to use chemical fertilizers, and that is going to be again entering the food system, the groundwater and everything else. It could happen if we use it while constructing buildings. You can see water just literally considered dead, in the sense it cannot support any life form, let it be planktons or fish. You will just find them choking and dying in so many areas. It is just because of high levels of pollutants in the water, especially metals like mercury and lead. So, what exactly is water pollution? Water pollution occurs when pollutants are discharged directly into water bodies such as rivers, lakes and seas. It also occurs when air and land pollutants are blown by wind or washed by rain into water bodies. So, basically this is seen mostly in urban settlements where discharge comes from different forms of pollutants into canals, drains and the sewer pipes, and even rainwater pipes which is laid down separately, which eventually finds its way into rivers and seas. So, sources of pollutants include factories, sewage treatment plants, runoff chemicals from agricultural plantations and livestock farms. If you look at the scene over here, you can see the different sources of pollution. Here it is entering the rainwater, directly the stormwater drain. Here you can see if you use fertilizers abundantly on your lawn to just make it look green and flourishing, it is going to affect. And here the people are just taking care of their car, but again the fumes or the fuel, any leakage from that is going to go into the water, and anything that we throw or whatever that we throw around on the ground, it is going to clog the drains, and again if it does get in contact with the water, it is going to pollute the water. So, every small action of ours does cause damage to the environment, especially our water. Water is obviously essential to life on earth, that is irrespective of any type of life. Organisms are composed of so much water as 70 to 95%, supportive external environment for aquatic organisms, cellular medium within which biochemical reactions can occur, transport medium for food, oxygen and other things required by cells, means of transportation, that is turgid plant cells or hydrostatic animal support systems. Three forms of water: solid, liquid as well as gaseous. So, solids, when water becomes very cold and freezes, it will change from a liquid to a solid state, and this has a definite form and shape. When water takes the form of its container, it is considered to be in its liquid form, and when water is seen as a vapor form and has no definite size or shape and cannot be contained as such, it is in a gaseous form. So, if you look at distribution of Earth's water, saline, that is salt water, is about 97% and a mere 3% is fresh water, and within the fresh water 68.7% is encompassed in ice caps and glaciers. Then you have groundwater about 30% and other sources for about 0.9%. Now, the surface water that we see, how does it come under? Lakes is 87%, swamps 11% and the rivers is a mere 2%. So, if you actually look at the water that can be consumed directly by man and plants, is just a meager 3% of the total Earth's water volume. 97.2% of the Earth's water is just salt and barely 3% is fresh water. So, like we just saw, glaciers, permafrost, perennial snow encompasses nearly 70%, fresh subsurface water nearly 30%, and rivers a mere 0.006%, swamps 0.03%, soil moisture, that is the top soil has a permanent moisture set across and that acts like a storehouse for most plant organisms, that is about 0.05%. Atmosphere as in water vapor, you have 0.04% and freshwater lakes about 0.25%. If you look at the water supply, you can see the decreasing percentage from a whopping 97% of salt water to the right 0.001% of atmospheric moisture, which is basically responsible for any form of precipitation. Only this comes down as snow, rain, fog, smog, whatever that is there, it is only this small percentage. Earth is considered as a water planet. It is unique amongst other planets because of its abundant water, let it be in oceans, in the atmosphere, in glaciers as well as fresh water on the land. Without water, life can basically not exist. Like we just discussed, about 3% is only fresh water or potable water. 2% of the Earth's water is all in solid form, which is found in ice caps and glaciers. 1% of all Earth's water is in usable form to humans and land animals. This fresh water is found in lakes, rivers, streams, ponds as well as in the ground. A very small percentage is in vapor form in the atmosphere. So, you have distribution of water, ocean water, fresh surface water, this is basically rivers, lakes, streams, ponds and similar bodies of water. Groundwater is under the ground as storage reservoir. The majority of planet's liquid fresh water is stored in underground aquifers or reservoirs. Water has entered an aquifer, remains there for an average of around 1400 years. But now that percentage is again reducing because of a constant demand and the supply is not enough to meet this demand. So, we are going further and further, deeper and deeper into the womb of the earth to get more and more water. Water that has been there for thousands of years are now getting consumed within a matter of few years and not getting replenished as fast as the way we are consuming it. Water, a precious natural resource, we use it for drinking, irrigation, industrial purposes and energy production. Agriculture and energy production takes about 80% of the chunk. Industrial and public use, that is human use, is about 20%. We use it as a nourisher of plant and animal life, a bearer of food, a prime element of industrial processes, and a medium for transportation like in ships and boats. Significance of water. Water is an integral part of life on this planet. It's an odorless, tasteless substance that covers more than 3/4 of the Earth's surface. Most of the water on Earth is found to be in oceans as salt water, and we cannot consume this water or use it for crops because of the high percentage of salt content. But we do have now methods to remove the salt from the ocean water, but this process is very expensive. At the end of this lecture, we have seen air pollution and have specifically seen ozone depletion and its different aspects. We have looked into water pollution as well. At the end of this lecture, we should be able to answer the following questions. What is ozone? What are the effects of ultraviolet radiation? How is water distributed on Earth? What is water pollution? That brings us to the end of this lecture. Thank you.